Welcome back. Let's have a look at one more kind of annuity to get us started here with annuities, and that's an ordinary general annuity. With an ordinary general annuity, we've got a situation where the interest rate conversion period doesn't match the frequency of the payments. So up until now, we've had that happen, haven't we, where the rate happened to be a J12 if the payments were monthly, or if the payments were quarterly, the rate was a J4. Well, what if they don't match? If that's the case, then we've got what we call a general annuity, the more general case. Now, in order to solve those, really, we can just follow a two-step process. First, we're going to convert the general annuity into an ordinary simple annuity by converting the interest rate. Once we've got it there, then we can just go ahead and solve it using all the formulas we've already learned. And if you think back to our last chapter, we had a formula for converting interest rates, didn't we? We learned how to convert from one nominal rate to another, and that was this formula here. I2 is equal to 1 plus I1 to the power of M1 over M2 minus 1. And the 1's and 2's just stand for the first and second rate. First rate is 1, we know. The second one is the one that we want to end up with. So for example, if I am given a rate of 6% compounded semi-annually, but my payments are monthly, I'm going to want to convert that 6% semi-annually into a J12 or a monthly compounded rate. So here's how we do that. We'd say, look, we've got over here on our first rate, the one we know, we're compounding twice a year, and the interest rate per period is going to be 0.03. On the one I'm trying to find out, well, that one has to go 12 times a year to match my monthly payments, and I don't know the I2 yet, do I? So let's go ahead and plug the numbers in here into the formula. We have 1.03 going from semi-annual to monthly, 2 over 12, take away 1. And that's 0.004938622. That's often good enough at this point because with our annuity formulas, remember, we're putting I in, aren't we? So we could really just stop here. I know in the past we would then take that and say, okay, times 12 times a year gives me a J12 equal to 5.93%. And you can still do that if you like. But don't forget, when we get to the annuity formulas, it's little I that we really do care about. So we could actually just stop part way. Let's have a look. Before I go too far, though, I want to give you a chance just to practice converting some rates in case you've sort of gotten a little bit rusty on that from last chapter. So try these out. If you're given 6% compounded monthly, but the payments are quarterly, could you convert the rate to a quarterly rate? I guess get little I and also do the J4, why not? And then do it again. For 5% compounded annually, could you find the J12? And 8% compounded quarterly, could you find the J2? Go ahead and hit pause for a minute while you work on these, and then when you're ready, come on back, hit play, and see how you did. Let's have a look. In this case, I've got my first M is equal to 12, isn't it? And my first I here is going to be 0.005, and I'm looking for a quarterly compounded rate. So my little I is going to be 1.005, going from monthly to quarterly, 12 over 4. Sometimes people think that can't be right. It has to be 4 over 12. But the order is dependent upon what I'm converting from and what I'm going to, isn't it? So this is correct. Equal to 0.015075125. Very important to keep all your decimals at this point as well, isn't it? Because if you were to round that to 0.015, you'd be quite a bit off when you did your annuity calculations. Now, if you took it all the way to get the J4 as well, just out of curiosity, that works out to 6.03%. But like I say, for our annuities, we're going to be using the little I, so that's fine. The one that I've underlined there. Let's have a look at the next one. In this case, we're starting with annual compounding. And we want to get a J12 rate, or at least a monthly rate to work with. So our I2 is going to be 1.05, going from annually to monthly, Take away 1. That's 0.004074124. Or, if we convert that all the way over to get our J12, be 4.89%. At this point, you're probably thinking, okay, I remember this, but let's do one more. Right? So here I had an M of 4 and a little I of 0.02, and the M that I'm caring about here is going to be twice a year. So I2 is going to be 1.02 going from quarterly to semi-annually. Take away 1. That's 0.00404. And if you converted it over, that would also be J12 is equal, or J2 I mean, is equal to 8.08%. That's great. If you got those right, you're perfect at converting rates. That's all you need to do. If you're a little bit rusty on those, actually jump back to the previous chapter and have a look. Do some rate conversions in that section until you're getting really good at it again, and then come back and carry on from this point. All right, so now that we've got the rate converted, we're just going to use the same formula we had before for step 2. So future value is payment times 1 plus I to the power of n minus 1 over I. Just this time we're putting in the I2, aren't we? The rate that we've just determined. So we can just go ahead and do what we've already learned how to do. All right, let's put it to practice. Let's try an example here. At the end of each month, for 6 years, Jackie deposits 100 into an account, earning 9% compounded semi-annually. Let's find the value at the end of 6 years. And so if we have a look at these, we can see a couple things on the go here. The deposits are monthly, but the rate is semi-annual. They don't match anymore. That means we've got a general annuity. So let's go ahead and write down what they've given us. We're doing deposits here at the end of each month for 6 years. So I've got 6 years of monthly deposits. It's going to be 72 deposits, so that'll be N. The payment each time is $100, isn't it? They gave us J2 is equal to 0.09. Now if I'm gonna, so that means that little I is equal to 0.045 and M is 2. So let's convert that over. My I2 will be 1.045 going from semi-annually to monthly. Take away 1, which is 0.007363123. So there I've sort of done my step 1 already, haven't I? There's my conversion. Now let's go ahead and solve the annuity. Future value 100 times 1.007363123 to the power of 72, take away 1, divided by 0.007363123. I'd be thinking that's a lot of decimals. Do we really need them all? We really do, because if we were to round this even a little bit, it's going to get raised to the power of 72. That's going to introduce a lot of rounding errors. So keep all your decimals. If you're putting them into your calculator, go ahead and use those store and recall buttons to store your rate so that you can bring it back in all of its precision. Go ahead and work that out, and I get $9,450.90. That's how much Jackie will have in her account at the end of those 6 years. I'm going to give you a chance to try one out now. We've got Omar here planning on contributing $500 at the end of every 3 months, so that's quarterly, isn't it, into a savings account earning 5% compounded annually. How much is going to be in the account after 10 years? Go ahead and press pause and work through this. Don't forget, do both steps. First convert to rate and then solve the annuity. And I'll come back in just a second and work it out with you as well. All right, let's have a look. I've got a payment here of $500 per quarter. You could even write that in there if you wanted so you wouldn't forget it. But they gave us a rate of J1 equals 0.05. Okay, right away I can tell I've got a general annuity, don't I? My, well, I'll just, actually let me leave that for a minute. Let me write down N first before I go too far. I've got 10 years and the payments are quarterly. It's the payment periods that count, isn't it? So when I'm working out N, I'm counting it on or basing it on the payments. So I'll get to do 40 deposits, right, or 40 contributions. And I want to find future value. I might as well write all that down. Now let's break it down into our two steps. We were given J1 is equal to 0.05. That means M1 is equal to 1, and I1 is equal to 0.05, isn't it? We also have M2 is equal to 4 because we want to go with quarterly. So let's see if we can write and work out I2 now. It's going to be 1.05 going from annually to quarterly. Take away 1, 0.0122722234. So we've got that. Now let's go ahead and do step 2. Right, so step 2 says let's solve for the future value. That's going to be $500 times 1.0122722234 to the power of 40 minus 1, all divided by 0.0122722234. Plug that in there, and I get $25,622.66. I hope you got the same. Let's have a look at present value now, because we've worked that out as well. Well, the present value, we can do the same formula and really the same technique as before. So we use our present value formula, but again, we have to work out I2, don't we? So we've got the proper rate. Let's have a look. I'm just going to give you one to try because really there's not a lot of difference with this. The same process, just a different formula. So in this case, Fred has just won $1 million in the lottery, and he wants to invest a portion of it enough so that he can have monthly payments of $5,000 for 20 years. He figures that'd be perfect. And then anything left over, if there is some left over, well, I guess he can just go have a bit of fun with that right away. So if he deposits his money into an account earning 4% compounded semi-annually, so there we got a semi-annual rate, how much should he set aside out of his $1 million? Just like always, go ahead and hit pause, and when you're ready, you've tried it out, hit play again, and I'll go through it with you. All right, I'm going to just start by writing down some of the basics we've got. Fred would like a payment of $5,000 per month for 20 years, so N will be 240. You want it 12 times a year for 20 years. I'm going to go ahead and convert my rate first. So the first step is to convert the rate. And can I just dive into it? Let's see. I've got 1.02 going from semi-annual to monthly. Take away 1. That's 0.003305.890. Now, if that was too quick for you, let's think for a minute. We had a J2 is equal to 0.04. So the M for that is 2, and the I for that is 0.02. So can you see where I got the 1.02 from? And I'm going from semi-annual to monthly, so 2 over 12. My M1 is 2. My M2 is 12, wasn't it? So that's where I got that rate from. Hopefully you can kind of do them that quickly now as well. And you don't have to write down every little detail once you get good at them. You can just move on and get them done. So let's have a look. We want to do the present value. In this case, that's going to be 5,000 times 1 minus 1 plus I2. I guess if I label that as I2, I don't have to write it again, do I? I've got it written down once, and you've likely got it stored into your calculator, so that's okay. And I don't mind that. If you ever come to an exam situation with me, you've written the interest rate down once, and then right below you go ahead and use it. Well, just write the name of the variable. That's fine. I know you've got it at that point. And if we work that out, $827,476.91. So that's how much Fred should put aside out of his lottery winnings. So the remaining 170,000 or so, I guess he can go out and maybe buy himself a sports car or something fun and enjoy it. And he can rest easy knowing that he'll still get $5,000 a month for the next 20 years. That's it for general annuities. Go ahead and practice lots of those and finish up the chapter and work through the chapter review as well. And I'll see you again next time.